this gradient of a tangent, also known as the slope of a tangent. This is kind of what we've been building up to, right? The whole idea is, how do you find the slope of a tangent line? How do you find the slope of 1 point? We can find the slope of 2 points pretty easily. How do you find the slope of 1 point? And that's to find the slope of a tangent line. And that's what this lesson's about. So the way you find the slope of a tangent line is by using this formula right here, the limit as h approaches 0, f of a plus h minus f of a all over h. What does that come from? Well, this is just literally the function, the slope equation, f of y2 minus y1. I wrote that bad. x2 minus x1 over f of x2 minus f of x1. Right, this is being y2 and y1. It's the slope equation. Right, so this point here, you can think about that point there as x1, y1. And a point up here, think about that as x2, y2. Remember what he said before is that we're going to get this closer and closer. We're going to move that point like here, and move a point here, and we're going to take the slope of all these points, and then we're going to take a look at that. The distance between those two things is what we're calling h. This distance between this and that is what we're calling h, this distance there. And as that gets smaller, right, as you talk, instead of being that whole point, it's to this one, that's h. And then to this one, oops, that's h. So we're going to keep on doing that until h gets really, really small. That's why we're taking the limit as h gets close to 0. Where the difference between this point and that point is almost non-existent. It's essentially 0. And you get this equation. Like, that's what this is. Well, when that happens, this is f by 1, and then this is literally just the distance between your a and h. That's like what y2 would be. So that's where this formula comes from. So that formula, that's just where it comes from. It's just like, oh, we're taking the limit as we get closer to h. So how do we use it? So let's do it here. So find the gradient to the tangent line of this at the 0.24. So we're trying to find the slope of the tangent line of x squared at 0.24. So we're going to use the formula, the limit as h approaches 0 of f of a plus h minus f of a over h. Now in this case, a is 2. I honestly don't need the y value. We're going to find the y value in here, but that's what a is. A is the x value. A is 2. So this is really just the limit as the h approaches 0 of f of 2 plus h minus f of 2 all over h. Okay, so let's talk about this one by one. What is f of 2? F of 2 is literally the function at 2. What's my function? X squared. So f of 2 is just the function x squared at 2. So substitute in 2 for the function. So I get 4. That's where the 4 comes from. That's what this value here is. Okay, so this is what everybody kind of freaks out about. What's f of 2 plus h? Kind of the same thing. So f of 2 plus h is the same concept. We're going to substitute into this equation, x squared. But in this case, right, something squared, the thing I substituted in here was 2 into that equation. In this case, the thing I'm substituting is all of this, 2 plus h, into that equation. So I'm going to get 2 plus h squared. So let me rewrite this, the limit as h approaches 0 of 2 plus h squared minus 4 over h. Now the key here is you got to simplify this. There's no shortcut to it, you just got to simplify it. And we can't be lazy. Don't give me this 4 plus h squared. That's not what this is. Right? This, when you square something, you multiply by itself. So 2 plus h times 2 plus h. You can't just square both terms because there's a positive sign there. This is a binomial. You can't do it to binomial. You can do it to monomials. You can't do it to binomials. You just have to multiply by itself. Then we distribute. 2 times 2 is 4. 2 times h is 2h. Move on. H times 2 is 2h. H times h is h squared. If I add like terms, like add these middle terms here, I get this. The limit, I'm going down now, limit as h approaches 0 of 4 plus 4h plus h squared minus 4 all over h. Right, so where this, all this came from this guy, and the 4 came from my original thing right here. So let me highlight it. Right, so that's where those values came from, right? F of 2 plus h, if I was to substitute into the equation, x squared, I got this, which gave me this, which I simplified to this. And f of 2, substitute 2 into the equation, you get 4, and you get this. And now we just do some algebra. Positive 4 minus 4, those things cancel out. And I'm left with just this. The limit, as h approaches 0, of 4h plus h squared over h. Now, we have a limit problem. Remember what I always said about limit problems? These are ugly h's, I know. You want to substitute in 0, and as long as you get a number, you're good. If you get 0 over 0, you have some work to do. What happens if I substitute in 0 here? I would get 0 plus 0 over 0 or 0 over 0. So I still have some work to do. Remember, in IBAA SL, it just means factor. And look at the top here. I could factor out an h. So let's do that. Limit, as h approaches 0 of h, 4 plus h over h. Right? I factor out an h, they both had one. I get this. I'll put the 4 plus h inside. These cancel out, and I get the limit as h approaches 0 of 4 plus h. And then now, you can substitute your limit in. That's the whole point. You want to be able to substitute the value in. So substitute in 0 for h, and I get 4 plus 0, which is 4. And that is the slope of the tangent line of x squared at 2. So again, what's going on there? If you look at the graph of x squared, we're saying at the value 2, that point right there, the slope of this tangent line that we could draw, right? Tangent line hits it at one spot. The slope of that line, if I actually do the math on it, would be 4. That's what we're saying. So at 2, the slope of the tangent line is 4. Let's do another quick example. Maybe we'll do it easier the second time. Now let's make this up, because I didn't have this planned. Let's do f of x equals, we'll do an easier one, 3x plus 1 at x equals, let's say 2. Again, just to change it up. So, on this one, if I was using the equation, limit as h approaches 0 of f of a plus h minus f of a all over h. Okay, so remember, if we're doing this same thing, this is my a. So a equals 2. So I'm going to substitute it in here so you can see it. So we get really this. The limit as h approaches 0. I'm going to put L for short now. F of 2 plus h minus f of 2. Now remember, I always like to show more work than you generally have to, because I want you to see every step I'm doing. So like here, f of 2. Where do I get f of 2 at? Remember, that's just the value of f at 2. I substitute 2 into my equation here. So f of 2 is just going to be 3 times 2 plus 1, which is 6 plus 1, which is 7. So this is just 7. How about f of 2 plus h? Remember, that's just by substituting in 2 plus h into my function, f of x. So, right, f of 2 plus h. So, same concept. What is a function? A function is just 3 times something plus 1. And in this case, over here we plugged in 2. Over here we're substituting in 2 plus h. So we can distribute that and get 6 plus 3h plus 1. Right? 3 times 2 is 6. 3 times h is 3h. And then there's a 1 on the outside. So if I want to simplify this a little bit, I get 7 plus 3h. Right? Adding the 6 plus the 1. So that's what goes here. I wish I would give myself a little more space to do that, but that's what goes there. Okay, let's rewrite everything. So now this is the limit as h approaches 0 of 7 plus 3h minus 7 over h, sorry. Right, so that's what this simplified to, and that's what that turned into. Here, my 7's cancel out. Love that part. I get the limit as h approaches 0 of 3h over h. And now look at the h's cancel. I just get 3. Now in this case, there's nothing to plug into, so I don't plug 0 into anything. My limit's just 3 no matter what my a was. And that makes sense if we look at the graph of 3x plus 1, right? The graph of 3x plus 1. So, y-intercept of 1, slope of 3, so 3 over 1. Graph like that. It's a constant line. The slope everywhere is 3. So no matter what point I pick, my slope is always going to be 3 because it's a line. And the slope of the tangent line is literally just the slope. Anyway, that's the lesson.